Well, so now we have to discuss about the compound microscope, which has two lenses. One is objective and other is that is the ocular. So one is objective and other is that is eye lens. So objective lens and eye lens, ocular. So in compound microscope, we use two convex lenses and there is a typical length of the tube in which the two lenses are used. And the purpose of the compound microscope is to magnify a micro object like a virus or a bacteria or the blood cells or the RBC and WBC, white BC, that is white blood corpuscles. So now we come to the main concept here, that is the construction of the compound microscope. As I have explained that it has two convex lenses. So what we are finding that it consists of the two convergent lenses of short focal lengths and apertures. Aperture means the curved surface arranged coaxially, that is on the same axis. So lengths of the focal length f0. F0 means the focal length of objective. F0 facing the object is called objective or the field length. While the length of focal length FE, that is the focal length of eyepiece facing eye, is called eyepiece or the alternative name is ocular. So for eyepiece, normally in optics we use ocular or it can be eyepiece. Now the objective has a smaller aperture. So field length has smaller aperture means that it has very less curvature and smaller focal length. So objective focal length is less, then focal length is less than eyepiece. Eyepiece means ocular. The separation between the objective and the eyepiece can be varied. Now the image formation, we can see like this. The object is placed between f and 2f. Well, we consider a lens, that is the objective lens, and for that objective lens we select the principal focus and double of the focal length, and the object will be placed between f and 2f. So the image I am formed by objective called intermediate image. So IM stands for intermediate image. It is inverted, it is real, and it is enlarged. When we say that it is real, it means we are expecting the image on the screen and at distance greater than f0. On the other side of the lens, this image, that is intermediate image, IM, acts as object for the eyepiece and is within its focus. So intermediate image is at the focus of the eyepiece or the ocular. So eyepiece forms the final image eye, which is erect, virtual and enlarged with respect to the intermediate image, and so the final image eye with respect to object is inverted, virtual, enlarged and at a distance d to infinity from eye on the same side of the eyepiece or the ocular. This is shown in the figure. Now we find there are two lenses here, one towards the left, other towards the right. Towards the right it is ocular or the eyepiece, and towards the left it is field lens, that is the objective. So for an objective lens, the focal length is f0, and for the eyepiece or the ocular, the focal length is fe. Then h is the original height of the object and object distance is u from the objective. Now object is placed at f0, that is the focal length of objective lens. The image will be formed at, that is h dash. So we will find that h dash is the length of the image formed by the objective. Now this image will work as a real image, or this image will work as real image for the eyepiece, and finally the image will be formed at f0, that is represented by I. So it means that this image will be that is inverted, magnified, and towards the side of eyepiece. It will be a virtual image. So this fact is applied for magnifying or the enlargement of the object. So we come to the main context now. That is magnifying power. Magnifying power of an optical instrument is defined as. Now again, the definition is almost the same as that in case of a magnifier. Visual angle with instrument divided by maximum visual angle for the unaided eye. Unaided means when lens is not used, and visual angle with instrument means with compound microscope. So two angles are given, that is with instrument it is theta, and without the instrument it is theta naught. So theta naught is the visual angle without compound microscope, and theta is the angle when we are using compound microscope. If the size of object is h and the least distance of distinct vision is d, that is 25 centimeters, then the visual angle theta naught will be given as h dash over ue multiplied by d over h. And this can be written as h dash over h, and then it is multiplied by d over ue. That is, ue means the distance of eyepiece or distance of object from the eyepiece. D is the least distance of distinct vision. And h dash is the height of the image, where h is the height of the object. But for the objective, m is I over o. That is size of image divided by size of object. Or magnification can also be given as the distance of image divided by distance of object. That is, h dash over h will be equal to minus v over u, as u is positive. Magnifying power can be calculated by minus v over u, that is f over ue with the length of the tube. Now length of the tube is calculated by adding the image distance and that is distance of object from the eyepiece. So we will add these two values algebraically because length is a scalar. If the final image is at infinity, that is at the far point, this situation is called the normal adjustment, as in this situation eye is least straight, that is without the lens, or relaxed. In this situation, as for eyepiece, v is equal to infinity. Now 1 over minus infinity minus 1 over minus ue equal to 1 over fe, that is focal length of eyepiece. So ue will be equal to fe, and that is will be maximum. Actually, when we write 1 over minus infinity, infinity is number over 0. So 1 over minus infinity as a whole will become 0. And the second term is negative with denominator also negative. So it will become positive. So 1 over ue will be equal to 1 over fe. And from this, we can conclude that ue must be equal to fe, and that will be maximum. Now, substitution of this value of ue in equation number 1, then we can get minus v over u into d over fe with L is equal to v plus fe. This is the second equation, and that is the equation for magnifying power. Now, a microscope is usually considered to operate in this mode. In this mode, as ue is maximum, the magnifying power is minimum for a microscope. So enlargement is not very fine. Now the C point is, if the final image is at D, that is the near point, that is 25 centimeters from the lens. In this situation, as for eyepiece, V is equal to D. Now when we say V, we are referring to image distance, and D is referred to the least distance of distinct division. 1 over minus d minus of 1 over minus ue equal to 1 over fe. Now we can simplify this equation and we can write 1 over ue equal to 1 over d into 1 plus d over fe, where fe stands for focal length of eyepiece, ue stands for distance of object from the eyepiece, and that is from the ocular, and d is the least distance of distinct vision. Now substituting this value of ue in equation number 1, and from that we get magnifying power as minus v over u into d over fe, and v, u, d and f are the usual meanings, and L, that is L is equal to length of the tube, that will be v plus fe d over fe plus d. Now we can mark it as equation number 3. In this situation, as ue is minimum, magnifying power will be maximum because it is an inverse relation and eye is most strained. That is, the lens is being used.